Hey guys, today I'm going to teach you how to make a Spider-Man-like web swinger using blueprints in Unreal Engine 4. This is predominantly a programming tutorial, so I'm going to briefly touch the particle effects. Okay, for starters, let's just set up an input events. So, we're just gonna make a swing. Let's map it to our left mouse button or whatever you like. Also, if you want, so far the swing is going to work on pretty much any substance. However, if you guys want to make it only work on specific channels, you can just set it here in the trace channel and then enable those in the collision options of that actor. Okay, so let's start by making our material and particle effect. So for starters, let's just make our web. The web is just a constant 4 of white. Plug it into our emissive color, and there we'll have our web color. Now let's go to our particle. Score spider web. Okay, now for starters, let's go to our required and add web. Okay, cool, that works. Now for initial size, go to start size, distribution, and let's just make all the maximums 3 and all the minimum 2s. Okay, initial velocity is next. Go to our start velocity. Let's make this all 0, 0, 0, 0, 0, and 0. Here we go. Alright, never mind. We don't have to touch this. Now we can delete our color over life. And now let's add actually a new beam. Actually, yeah, a beam data is something I actually forgot. Okay, first let's just make this a... Oh no, wait. Alright, never mind. This ended up stuttering a bit here. Okay, so beam data, let's make it 0, and always on is set to true. Now let's go to our initial color is what we need to make next. It's pretty much by default, it's already white, so we don't have to worry about editing it. Now let's make our, go to beams, let's make a source and a target. So for our source, all we need to do is, alright, never mind. For our source, we just need to make this all 0. So you can see our beautiful spider web's just coming to play. And now let's go to target. Let's make this into user set. And let's make our target distribution constants all, you guessed it, 0. Now that's that. Speed, color, am I forgetting anything? White, for particle effects. And yeah, that should be it. See our totally visible web. Just trust me, it's there. Okay, now that we're done, now for the fun stuff. So the script itself is actually surprisingly simple. With it has 5 parts with only 2 bulky parts. There's the swing, the web creation, detaching the web, the swing itself, and line traces. So let's first make our custom events. So let's actually create the web. Detach the web. actually. Create, detach the web, web swing. Web swing, there was one more thing I was forgetting. What was it? What was it? Let me just look at my notes. Web swing, oh yeah. Oh right, no man, I also have to make a function for the line traces, which I'm going to do it off the capsule. You can do it off whatever you want. I just like to do more match-driven things inside functions. Alright, then we have to put our input event for swing. So for starters, so we're gonna have one branch that's gonna check if the web is attached. If the web is attached, then we're gonna detach the web. Otherwise, we're gonna have to do a trace to check if trace, okay. So now let's work on our trace. So, okay, so first of all, we're gonna check if our character is in the air. Is in the air. Then we'll check. Alright, then we'll have to have a coordinate of. Wait, actually I messed that up there. Let me quickly fix this up. Oh yeah, then we're gonna have an array of points that that our character can grab. These we're gonna first clear that array. So because we'll be calling this array every time we pretty much left click. Clear array. Then we're gonna, oh damn it, we're gonna do our trace. Well, we're gonna look for points to attach to. To attach the web to, and then we're gonna oh man, I feel like I keep messing this up. Okay, we're gonna randomly assign the spider web to a grab point in that array I mentioned in that array. Web array in the array I mentioned earlier. So okay, so now let's actually start this. So first, let's check if our character's in the air. We're going to grab the character component, character movement component. Check if our character is either flying or falling. If true, then we know our character's in the air. Now let's just actually, to be honest, I should have actually just made my variables beforehand. So, never mind. We all get nervous at one point. Okay, so let's make a web array. And let's make this into an array, and let me change the name properly. Web array. So we're gonna clear this array every time we left click. Now we have to look for the point to attach to. So something which I like to do is use a for loop, because I'm gonna shoot multiple traces rather than a single line trace, and it'll randomly select between one of the traces that connect, so the web connection doesn't feel as robotic. So let's just make the first index 0 and promote this to and let's just promote this to a local variable called forward traces, and I'm gonna set mine to 12 actually. Yeah, why not 12? So after that, we're gonna have to do our line trace. Oops. Line trace by channel. Let's make this comment bigger, and let's shrink this one. Okay, so if the line trace connects, then we're gonna get our web array and we're gonna add the location of the point. So let's break the result, grab the location. So now that we have the result, so now for some maths. Okay, so I prefer to do my maths just in macros because it's a lot easier to manage. So capsule forward trace. So for output, we're just gonna just have a start and an end. Input we can just straight up ignore, actually. So for start, we're just gonna get the actor's location. And for the end, we're gonna actually do this off the character's capsule component. So we grab the component. We're actually, let me just make a comment for this so people actually understand what I'm doing. So we're gonna shoot a controlled random web trace. Web trace get up vector, and we're going to get the right vector, and now the only one and only forward vector. Okay, so we're going to have to multiply all of these by floats. So as I mentioned, that it's going to be a controlled random variable. So we need a random a random float within a certain range. Well, let's duplicate this all over the place now. Oh no. Alright. So for our up vector, let's restrict this from 0 to 1.5. So he can shoot up to a factor of 1.5 upward. Let's make right vector, let's make its minimum -1 and 1, so you can shoot left or right. Forward, let's make it 1, and let's go for 2.5. Probably. Now, you need to get the sum of these vectors. Normalize it. And multiply it by our web trace. Actually, yeah, our web trace length. So I'm gonna probably set mine to 7,000. Yeah, that seems reasonable. And then we will get the sum of these two. To get our endpoint. Thus. And thus we can just drag this macro in and attach it to our line trace. So let's just draw this for now. So the moment you complete the trace, let's just actually okay, so now we're actually gonna decide which point the character will grab onto. So let's start. Let's first check if our array actually succeeded. So if the web array length is greater than 0, that means something at least made it into the array. So this means that okay, wait. So we're gonna first minus it by 1, because arrays always start at 0, and we're gonna get a random int in range, width, set this to the maximum, set this to 0. Now let's get whatever random element we select in the array and set that to our grab point, which is going to be another variable that I make. Then we subtract this. Actually, let's make a macro for this. So what we're going to do is set our web length limit. So we don't want our web to get we don't want our web to ever get too long, otherwise it'll become otherwise there'll be a lot of slack. So our web point limit will just take our grab point, subtract that by the actor's location vector length, and then we will output this as our web length. So now we can just do this. We can grab our macro, set a variable to the web limit. Actually, our web length, which will actually change when we finally start moving. So let's do this. Okay, now let's actually create our web. Which was one of the first functions I told you, one of the first functions I made in the beginning. So, okay, after all this. Okay, so let's actually create our web before I do a test. So create web. So all we do is spawn an emitter attached. We're gonna attach it to our mesh. We're gonna spawn spider web. We're gonna snap to target while keeping world scale. And then I'm actually gonna, let's open up our skeletal mesh and let's take our character's right hand. So let's copy this over. From here, now we need to just save a reference to this, which we'll need when we have to delete our spider web. So let's call it web particle. After that's done, after we finish our web particle, oh yeah, we're gonna have to send the beam's endpoint. So endpoint will be set to that, and just and the new endpoint will be set to our grab point we got from the array. So let's comment this out. Creates web. Now let's actually see if this works. So let's check if our character's in the air. Actually, so something's not working here. Let me have a quick look. Right, I haven't done this yet. Actually, let me just see, did I miss it? Oh, right, yeah, I actually missed something. So just after you to get your grab point, we're gonna actually have to check if the web is attached. So no, let's do this. So now you can see our beautiful web. So that works. Now let's... Okay, so now let's actually move on to destroying our web. So... So, like, let's get the particle reference I made earlier. And let's just straight up destroy the component. Set web attached to false. And then we're gonna have to we're gonna have to actually reset the character's position. Yeah, so we'll get our capsule component, set world rotation. So we want to keep the same Z of our character, but we don't want X and Y to change. We actually want to reset X and Y, so our character doesn't reset in an awkward rotation. So let's split this. Let's actually, so X and Y will have to be reset to 0. Let's get actor location, split this, take the Z, and that should be it. So, detach web. So we have the web, left click, we've lost our web. We've got our web, lost it. Got it, lost it. So now, okay. Okay, so now we'll actually move on to the last part, the actual web swing, which I'll actually take some time to explain how this works. So firstly, we actually need to check our pawn's orientation. So check pawn's orientation. Then, wait, after my pawn's orientation, then we have to, oh wow, this is annoying. Align the pawn to the web. So we get so the pawn is actually looks like he's attached to the web rather than flipping into awkward rotations. Then we check. Oh, okay, wait, I keep doing this. Then we check if the web is short enough or too long. Over here, the last two parts is actually adding swing force, and oh damn it, I keep doing this. Oh well. Live and learn. Okay, then the last part is we're gonna shorten our web if it's too long. Okay, so okay, for starters, we need to actually check. We actually need to make a rotator. I'm so sorry, not a rotator. We actually just need... Oh wait, let me actually just check my notes again. Oh yeah, we actually have to just not. Oh no, wait, sorry. We have to set the pawn's orientation to the web, so he actually resets his position before swinging. So what we're gonna do here is set world rotation of the capsule component, because that's what everything's parented to. Oh no, sorry, I mean capsule rotation. World rotation. The rotate. Okay, so now we just need to make its rotation. I'll just prefer to do this into a function because maths, and it's and it's just something I like to do. So we're going to rotate character into position. Okay, from here we'll get the grab point, subtract that by the actor location. I'll explain this afterwards. So actor location, and then we normalize this. And then we're we have to return. Yeah, like, okay, we actually have to return a rotator, which is something I should have said at the beginning, but hey. So, yeah, let's just call this return rotation. Make a rotator of Z and Y. Okay, so now we have our Z. We need to now get our Y. So we're gonna get the velocity, normalize it, multiply these two vectors, and then this is something I'll actually explain to you guys later. Just bear with me. We're going to multiply it by a specific int later. For now, let's just set this to 1. Okay, connect these up, make it pure, and let's bring it in. Okay, so I'll just actually explain this now. Okay, so we kind of need to get we kind of need to okay, so the thing is, we need to kind of make sure the Z is within a set limit and changes only to the default of the character, because we don't want Z to be altered too much from its main character orientation. So we're going to orient it depending on the difference between the actor location and grab point. Then we need Y to change minimally, because this is our pretty much Y rotation. We don't want our character to turn too much in sideways angles. However, we do want changes in Z. So if he's swinging upward, downward, so he'll rotate the mesh accordingly. Hence, we need to rotate make a rotator of the Z and Y. Okay, and now let's move on to checking the web. Okay, so a branch. Let's make another function, because actually no wait, let's make another pure function, because why not? Check web length. So over here we're going to actually return a boolean to check is short enough. So what we're going to do is we're going to get our, actually, wait, let me have a quick look at this. Actually, yeah, I actually just made this, I just realized. Our web limit. So check if our web, so we're going to check if pretty much the limit we assign to our web. So if the web is greater than the limit, so our web length, then we can add a swing force to it. Actually, wait, I forgot to actually make this pure. And, yep. Pure, right. Wait, what? Oh, never mind. I just realized I wrote the same comment twice. No. Oh no, wait, wait, let me actually read. So align. So we're gonna align the pawn to the web. That's yep. So if true, let's start with the swing now. So let's add force to our capsule component. And now oh no, wait, no, wait, sorry, I was like to our character movement component. Add force to our character movement component. So now let's calculate the force. So we're going to get our velocity, get actor location, we're going to get, we need our grab point, so we need to first subtract our actor location by our grab point, then take the dot product of these two, and that will be our momentum, actually more or less force that will push us forward. And now we need to normalize these vectors. Yeah, physics has never really been my strong suit, but hey. Okay, this is something I will attempt to explain later, but for now, I'll just leave this here as -2. -2. And now, let's actually comment this out properly and place it somewhere nicely. Swing force. Oh. Okay, now let's shorten our web now. So if the web gets too long, it will, we don't want our web to ever get too long, to be honest. So we're gonna have to set our web length. So what we're gonna do is just actually take our web limit. And that's it. So now, let's see if this works. No, it did not. Let me just figure out why quickly. Oh, right. Lol. I actually forgot to call. I straight up forgot to even call the swing. Web swing. However, we actually just... However, I only want the web swing to be checked if the web is attached. So... And this is the basics of it. However, there is one problem. Well, actually, let me bring this a bit closer first. And I will actually decrease his jump velocity. Let's just make it 600. So if you look here, you can see the character kind of snaps into an awkward orientation at times. Actually, wait, to fix this, we just go to rotate character into position. We have to make this into -1 because when I was making this, when I actually properly set up the level, the character would actually will do a 180 turn if I was set to 1. Sorry, if I left this the default. Hence, I had to inverse it, and this should work a bit. Actually, wow, I think my maths may have actually. Oh well, never mind. Okay, so one kind of works here. Okay, might have just done a mistake in my other one. Okay, so the other thing which I'll try and explain. You can just stop pretty much here if you just wanted to know how to do it. Is this. So for example, if I leave it at 2, he pretty much flies off the map. So let's just make this -2 at first. So actually, let's just make this -1. So however, if it's negative or so, he stays intact. However, this is pretty weak, to be honest. So what I do is... So the reason why is because when you normalize a vector, you're taking the y coordinates off the character. You're taking all the coordinates, right? However, when you just multiply it by 2, you're pretty much swinging his y coordinate. The force pretty much swings out of... So upon relative distance... So pretty much when you normalize it, the y vector is pretty much, you get the inverse of, you pretty much get a negative y vector. So that pretty much sends it flying in this direction. I don't fully I don't fully understand it, but hey, it works. Okay, so now just 2 more things I'd just like to add. On jump. So I pretty much would like the web to be cancelled when you jump. So all you do is check, is web attached? If true, then detach web, and let's launch the character to make it feel like you pretty much slingshot yourself up. So I just would like to launch, I'll pretty much just launch off Z. Let's make him launch by 1,000. Actually, I actually would prefer to launch him just before I let go of the web, but otherwise the character's just gonna jump. That's one of it. Web swing, and the last one is on land. It's pretty much on land. I'd just like him to detach the web, so he, and let's see how this goes. Oh. It still needs more work, same as Trace, but hey, at least I've got the starting point, and I'm keen to see what you guys do with this. I hope you guys enjoyed my first tutorial, and signing off.